In this video, we will study 3 color balls combination probability with a sampling of 2. An urn contains 9 blue balls, 5 red balls, and 2 green balls. 2 balls are picked up at random without returning the balls to the urn. So the question is, what is the number of all possible outcomes or the number of elements in the sample space? So the first thing we do, we number the balls to make them distinguishable. So we number blue balls from 1 to 6, red balls from 1 to 5, and green balls from 1 to 2. So even though these 2 balls, they hold the same name, which is 2, but this is 2 blue and this is 2 red. So they are distinguishable right now. Or we can number them from 1 to 16. So the number of elements in the sample space for the case of any order can be computed from the combination formula under the condition of withdrawing without replacement. So we have total number of objects 16 and the sampling size 2. We are withdrawing 2 balls only. We substitute that in the combination formula and we get 120 total possible outcome. Question number 2. What are the possible joint outcomes from the standpoint of color ball? So let B represents drawing blue ball, R represents drawing red ball, and G represents drawing green ball. So we are starting with 9 blue, 5 red, 2 green, and for the first draw we may get blue, red, or green. And the remaining ball in this case after the first draw will be 8 blue, 4 red, and 1 green. Now for the second draw, again we may get blue, red, or green, and the remaining balls would be 7 blue, 3 red, and no green. And now we can get all the possible joint outcomes. So we may get blue, 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 red, red, green, etc. So these are the possible joint outcomes. And now we will group these joint outcomes into categories according to the kind of balls they have. So we will group blue and red, blue and green, red and green, and now we arrange them again. We turn them around and we will place them in order. And now these events, they are disjoint events and their union is the sample space. So these events, we write the name of each one and they form partition in the sample space. Question number 3. How many 2 blue balls can be withdrawn? So we are picking 2 blue out of 9. And now we have a sampling of 2. And the number of ways of picking 2 blue balls out of 9 is 9 combined 2, and that is 36. Question number 4. How many 2 red balls can be withdrawn? So we are withdrawing 2 out of 5. This is the first and this is the second, and now we have a sampling of 2. So number of ways, we are combining 2 out of 5, so this is 5 combined 2, and this is 10 possible joint outcome of 2 red. Question number 5. How many 2 green balls can be withdrawn? So we are picking 2 green out of 2, and that is 2 combined 2, which is 1. So we either have the first and the second, second and the first, and because we are not counting in order, the number of possible combination is only 1. Question number 6. How many 1 blue and 1 red balls can be withdrawn? So we are picking 1 blue out of 9 and 1 red out of 5, and now we have a sampling of 2. Now the number of ways of picking 1 blue out of 9 is 9 combined 1, and the number of ways of picking 1 red out of 5 is 5 combined 1. But before we continue, let us remember the multiplication principle of two events or sets. If event U has U objects and event V has V objects, then the product U times V or V times U represents the occurrences of both events in any order, and this is the case of the multiplication principle where order is not important. So there are cases for the multiplication principle where order is important, such as this case number 1 here, and number 2, and number 4. But for our case, we need the case of no order, since combination implies no ordered element. So we apply case number 3 for our question. So back to our question, we have two sets. The first one contains 9 combined 1 element, and the second set contains 5 combined 1 element. So to know the number of elements we can compose from both of them, we use the multiplication principle. So according to this principle, we multiply the number of elements from each set and we get 45 possible outcomes of combining blue and red together. Question number 7. How many 1 blue and 1 green balls can be withdrawn? So we are picking 1 blue and 1 green, and now we have a sampling of 2. So number of ways of picking 1 blue out of 9 is 9 combined 1, and number of ways of picking 1 green out of 2 is 2 combined 1. So now we use the multiplication principle. This is the principle here, and we apply it and we get 18 possible joint outcome of blue and green. Question number 8. How many 1 red and 1 green balls can be withdrawn? So we are picking 1 red and 1 green, and now we have a sampling of 2. So number of ways of picking 1 red out of 5 is 5 combined 1, and number of ways of picking 1 green out of 2 is 2 combined 1. We use the multiplication principle and we get 10 possible outcome of 1 red and 1 green together. So now we have the sample space with all disjoint event. So we will write for each event its corresponding number of elements. So for the event 2 blue, we have 36. For the event of 1 red and 1 blue, we have 45 elements, and so on until we finish. Question number 9. Find the probability of each disjoint event. So what we have to do, we have to divide every favorable outcome for each event over the number of elements in the sample space. So we do that for each event, and now we answered the question. Question number 10. Find the probability of picking at least 1 green ball. So we can pick 1 green or more. So this is one of the possible events, which is 1 green and 1 blue, or 1 green and 1 red, or 2 greens. So these are disjoint events, and their union form the event at least 1 green. So now let's find the probability. Probability of at least 1 green, it's either probability of green blue, or green and red, or green and green. So we add them together and we get 0.24. Another question, find the probability of picking at most 1 red. So we may pick up 1 red or no red. So we may pick up red and green, red and blue, or no red. And no red could be 2 blue, 1 green and 1 blue, or 2 greens. So the union of these events will give us at most one red. So we notice that this event, I'm picking two red. These two events are complement for each other. So in this case, the probability of at least one green is 1 minus the probability of picking two red, and that is 0.91. Question number 11, find the probability of picking at most two reds. So we may pick up two red here, or one red, or no red. So we may pick up one red, we may pick up no red. So all these events, they form the sample space. So this event at most two red is the sample space, and its probability is 1. Question number 12, find the probability of picking neither red nor green. So we are picking no red and no green at the same time, and that leaves us with one possibility, and that is 2 blue, because here there is red and here there is green, even though in this event we have no green but we have one red. So this event is not acceptable, and it's the same for all other events. So the event we are looking for is picking 2 blue, and that is neither red nor green, and its probability is 36 over 120 equal 0.3. So if we don't have the sample space diagram, we may use different way to answer this question. So we are picking neither red nor green, so it means we are picking only from the blue, and that is 9 combined 2. This is the favorable outcome of this event, and this is 36 favored outcome. And now we find the probability by dividing 36 over 120, and we get 0.3. Question 13, find the probability of picking no red. So we should not get any red, and that would mean 2 green, 1 green, 1 blue, or 2 blues. And the union of these events is the event no red. The probability of this event is the sum of these individual probabilities, and that is equal 0.45. Question 13 could have been solved in a different way, an easier one. So when we solved it before, we dealt with these two subsets, the green one and the blue one, as two separate subsets. And as a result, we had to deal with all kind of combination between them. So the first one was combination of blue and blue with this possible number of outcome, and the second one was blue and green with this possible number of outcome, and the third one was green and green with this possible number of outcome. So instead of doing that, we can deal with these two subsets as one subset. So we have the total number of element is 9 plus 2, and that is 11, and now we are combining two objects out of 11, and this combination actually is equal to the sum of all these combinations. So we don't need to go through all these combinations and adding them together. We can just do them in one shot, and now we can combine 2 out of 11, and we get 55 possible outcome. And now we can find the probability of this event of picking no red by dividing 55 over 120, and we get 0.45 as we did before. Thank you for watching, and have a nice day.